Okay. All right, we got a graph in a window. You got this rectangular window. A lot of times you'll make graphs on a calculator or a computer or your phone. Okay. And it's going to be in a window. So this window, you have x equals 10 here, x equals 50 here. You have y equals 40, y equals 200 here. All right. Can you draw the line? Go ahead and make a copy of this in your paper. Can you sketch the line? X equals 25. Where do you think x equals 25 would be? Go ahead and make this picture. And then see if you can figure out where the line x equals 25 would be. Okay, now we want to copy the picture faithfully. So you're going to have y equals 40. And I've got a dotted line here. And let's emphasize that dotted line. Y equals 40 on this dotted line. Y equals 200 on this dotted line. Here's a dotted line where x equals 10. Here's a dotted line where x equals 50. Now, where's 25? Well, from 10 to 25, it's 15, right? And from 25 to 50, it's 25. So distance from this line is going to be less than the distance to this line. So you can say, okay, maybe about here. Maybe that's where x equals 25, right? That's not totally accurate. I think it's too close here. But it's okay for our purposes. So if x equals 25, then can you make a point here where the x equals 25 line meets the graph? And then make a horizontal line to that point, and then try to figure out what y might equal at this point. That makes sense? Go ahead, just sketch that and then put some reasonable number for y. Okay, turns out everybody made the same estimate. There's apparently some kind of a psychological connection here. Okay, because nobody's sitting close enough to anybody else to have seen what anybody else would, but everybody said y equals 80. Okay. All right. Now, if I want to be more accurate about that, I can say, okay, well, between 40 and 200, there's 160. It's 160 units, right? And half that would be 80. 40 and 80 would get me to halfway. If I draw a halfway line here, I see that's going to be y equals 120. Okay. Another way, what's halfway between 40 and 200? How do you find a number halfway between two other numbers? This is something that's useful. Okay. So if I want to put a scale, that's one way to do it. Of course, you could already have a scale here, but usually I like to get people to think through the scale, to think through the numbers, and get a better orientation to the picture instead of just reading numbers off a picture, construct it, and think about what it means. Okay, so well, what's halfway between 40 and 120? Well, we can add 40 and 120. We get 160. Half that is 80. So 80 would be halfway between here and here. So, yeah, the way you drew your picture is different than the way I drew my picture. 80 was not an unreasonable estimate. on your pictures. Okay. Making it a little more precise in my picture, I'm just trying to get coordinate of y close to this line. If I go halfway from 40 to 80, I get 60. And, you know, this line isn't perfectly straight. But here would be my y equals 60 line. Right that way. So I'm going to say y equals about 63 here. Now that's not exact. That's just how you can kind of make an estimate. And you really want to be able to do that, even though Open Math isn't going to ask you to do much of that. They're going to give you the picture and they're going to give you the scale. And they're going to give you a grid, and then it's going to let you do it without thinking about anything. Okay? I recommend that you kind of think about it. If you're in my class, you're constructing these things. But if you're in a different class, you're not going to be doing these constructions. So I'm not going to emphasize that. Just try to get a feel for a scale on a graph and what the numbers mean and how you can think about the numbers. Does it make sense? Okay, and I could do the same thing here. From here to here, well, 10 and 50 is 60. You divide that by 2, so in the middle it would be x equals 40. And then I can cut that distance in half between 10, well, it's 30. From 10 to 30 is, well, 10 and 30 is 40, half of that is 20. So 20 would be about here. So that 25 that I just slopped down there wasn't too far off. All right. We say then, is the point, okay. The curve we're going to call the function here f. Now, function is just a rule. You give it a number, and it gives you a number. Okay? Makes sense? So if you give this function the number 25, the graph tells you that the function is going to say, okay, you give me 25, that's your input. I'm going to give you an output of 63. Okay, that would be the output of the function. So x equals 25 is the input, y equals 63 is the output, at least as far as I can estimate it from this graph. Let me there's something on my screen there. Had to go away. Okay. So does this make sense? Input, output. All right. Well, let's try to make a table here. Okay, we say get it right. We say f of 25 equals 63. This says if your input is 25, your output is 63. Make sense? So I'm going to put x here and I'm going to put f of x in this column. So if x is 25, f of x is 63. Well, let's estimate f of x for a couple more values of X, like, okay, what do you think f of X is if X equals 10? Think about it for a minute. According to your picture, what's your estimate for f of X if X equals 10? Or if X equals 40 or X equals 50. See if you can complete this table based on this picture. Okay, so when X equals 10, if we take the line X equals 10, the vertical line, make a mark here and project across here. Now, we're going to be between 40 and 60, probably a little closer to 60. So I'm going to estimate y equals y equals 52 on that line. Okay. So I'm going to put 52 right here. Where's X equals 50? At X equals 50, well, actually it looks like the graph hasn't gotten to the upper corner there, but let's just pretend it did. And we probably say y equals 200. X equals 40. Well, there's 10, there's 50, there's 30. Halfway between 30 and 40 would be here. It would say X equals 40 at this point. That gives me a point on the graph here. Come over here, and then I estimate this. It's between 80 and 120. I'm going to say y make me equals 100. So then I've got a table. Okay. Now, this is one way to see a function. Your input is your X value, your output is your Y value. So I can even say, well, Y equals f of X, right? Because this is the Y equals, right there it is. Okay. Now that's in terms of a picture of the graph. Among other things, not everybody can see a picture of the graph because there's people who might be visually impaired. But in another sense, we can have a formula for a function. Let's say we write f of X equals X squared plus 3. That's a formula for f of X. I think we did some of this last time where you replace X in the definition with numbers, right? So we're going to make a table. And we're going to use numbers for X like -2, -1, 0, 1. As we did last time, when X is -2, okay, over here to the right, I'm going to write, okay, f of -2 equals -2 squared plus 3. Make sense? Because I'm just plugging 2 into the definition. So write out the corresponding expression for each line. Now don't write it here because we're going to calculate this, and then we're just going to put a number in here. Okay. So off to the right, complete this calculation column. I'll actually even make a column for calculation. Okay. Now, what we're doing in this column is we're replacing X everywhere in the definition of the function, which means we're going to write the F on this side and the equal sign. Now, everybody's writing pretty much the right stuff, but not everybody's always writing the F thing. So we're translating the definition. This is important at this point. You want to get in that habit so that you always understand what you're doing, okay? So I just write out the definition, replacing the number by, replacing X by its value. Now notice that I've got a parenthesis around the -1. It's the -1 that's getting squared, right? Because X is -1, you got to square the whole X. And there's a difference between -1 squared -1 squared without a parenthesis. By the order of operations, you square the 1 first and then apply the negative. On the other hand, if you square -1, well, that's -1 times -1, which is +1. So there's a big difference there. Put it into your calculator the wrong way, the calculator is going to give you a problem. Okay. Okay, anyhow. The rest of the lines are going to read f of 0 equals 0 squared plus 3. F of 1 equals 1 squared plus 3. I don't really need the parentheses around the 0 because it doesn't have a negative sign on it. And I don't need it around the 1 and the 2. Okay. Then we can do the arithmetic. Now we do the arithmetic pretty much in our head. If you square -2, you're going to get 4. Add 3, you're going to get 7. Square -1, you're going to get 1. Add 3, you're going to get 4. Square 0, you get 0. Add 3, you're going to get 3. And then here you're going to get 4 and you're going to get 7. Now, I strongly recommend when the numbers are small and easy to do, you don't punch them into a calculator. You do the calculations on your paper. Okay? And I do want you to keep a notebook for this course, and I'd like to see that in your notebook. I'd like to see that you're actually doing the calculations instead of relying on the calculator. Now, if the numbers are this small, you should be able to do that, okay? If you got numbers like 348 and stuff like that and have to do something complicated, or if you got to do a square root or something, you're going to need the calculator. But don't use it unless you need it. If you're dealing with single-digit numbers for sure, do them yourself. Otherwise, you don't build the kind of intuition and understanding you need to really understand the functions. Okay. Well, that's the idea. Open math in the assignment. We'll just build on that idea. You got inputs, you got outputs, it'll tell you all that. Okay. It's going to give you videos, going to give you examples, more stuff than you probably want to look at. But these are the two big hang-ups people have. Number one, substituting into the function. I see people at the beginning make all kinds of mistakes. Okay. Like not putting parentheses around the negative quantity. Okay. And not really understanding what's going on. I'm going to ask you to do one more with the function notation, then we're going to move on to something else. Tell me what you think f of 4 minus f of 7 is. And by this, I mean, you write this out, you plug the 4 and the 7 in. You don't necessarily put the f of x equal, but you put the number into the formula, write out what you get, okay? And then what's f of 4 minus 7? Okay, on this first one, let's just write it out carefully. What's f of 4? Well, if you write out the definition, you get f of 4 equals 4 squared plus 3, right? So you're going to replace f of 4 with 4 squared plus 3. And then f of 7 is, well, if you plug in 7, f of 7 is 7 squared plus 3. So f of 7 is 7 squared plus 3. And a lot of times I see people writing f's down here, but you already have the f. F of 4 tells you plug in 4 here and then plug in 4 here. And f of 4 is this. There's no f on this side, okay? And that's a very common thing. I see that in just about every class. So that's 16 plus 3 minus 49 plus 3. And that gives us 19 minus 52. And that's negative 33. So from here down, from plugging the number in and writing down exactly what the function gives you, the rest is just the arithmetic. And do the arithmetic, but after you do the arithmetic, punch it into your calculator and make sure they agree, okay? Because a lot of times you're going to have to plug things into a calculator because the numbers are just ridiculous. All right, now what's f of 4 minus 3? What are you going to do here? Well, that's different than f of 4 minus, or f of 4 minus 7 is different than f of 4 minus f of 7. F of 4 minus 7 is f of negative 3 because 4 minus 7 is negative 3. And that equals, well, by the rule, that equals square of negative 3 plus 3, which is 9 plus 3, which is 12. Okay. All right. I think that should give you a good start on the function notation. All right. So let's go back to our original example. The domain of the function consists of all the x values. Now, our first graph showed a curve within a window. The window was located between the lines x equals 10 and x equals 50. Within that window, I drew a curve from near the lower left-hand corner, curving gradually and then more and more rapidly upward until it hit the upper right-hand corner, okay? That curve was continuous. So that any x value between 10 and 50 is going to give you a line that hits a point on the curve, okay? So I'm going to actually kind of highlight that line between x equals 10 and x equals 50. And I'm going to say that every x value along this line is in the domain. So now I'm going to have a picture of the domain. It's just going to consist of that highlighted line from x equals 10 to x equals 50 along the bottom of the window. And here's my domain. My range is a set of all y values. Now, y values, the window goes from the line y equals 40 to y equals 200, right? Are there any y values in there where a horizontal line wouldn't hit the curve? Are there any horizontal lines in this window that would fail to hit the curve? And I think we'll talk about this for a second. Okay, now the curve doesn't start at the lower left, doesn't start on the lower edge of this window. It doesn't start at y equals 40. It starts a little higher than that at what I estimated was y equals 60. The lowest point on that curve is at y equals 60. Okay? So the numbers between y equals 40 and y equals 60 are not members of the range. The range starts here and goes up to here. That interval is the range. In this interval down here, that we don't normally label, but I'm going to draw a little segment along the x equals 10 line from the lower edge up to the lowest point. And I'm going to say that's not in the range. Okay, so now how do we notate that? We say that the domain is all x values from x equals 10 to x equals 50. And I'm going to say that's inclusive. That means it includes 10 and 50. In interval notation, the domain is the interval 10, 50. Starts at 10, ends at 50. And I use square brackets around the 10, 50. So the square bracket next to the 10 indicates that 10 is in the domain, and the square bracket on the other side indicates that 50 is in the domain. Now the range according to my estimates, the lowest y value was 52. Okay. I estimated for the point on the left edge where the curve meets the left edge that y equals 52. You would have had a different estimate, most likely. But if my estimate is correct, according to my estimate, we'll say that the range is all y values from 52 to 200 inclusive. The range is the interval 52, 200. with, again, the square brackets indicating that the 52 and the 200 are included. There's a picture. Again, the picture is of two vertical lines, x equals 10 and x equals 50. X equals 50 to the right of x equals 10. And now two horizontal lines represent y equals 40 and y equals 200, intersecting those two vertical lines, and then a curve starting at the point on the left edge where y equals 52, in other words, just above the lower edge, and rising more and more quickly until it hits the right edge at y equals 200. Domain is all the x values from 10 to 50. The range is all the y values from 52 to 200, and both of those are inclusive. Now, open math and your 161 class will tell you a little bit more about how to notate intervals, but that's easy. Okay. Open math will let you know if you do it wrong too, but you're probably going to do it right. All right. Now, sometimes you're given a formula for a function. So there are two primary things that restrict your domain. There are others, but there are two primary things. I'm just going to illustrate those with a couple of examples, okay? So let's suppose your formula for f of x is f of x equals 1 over x minus 12. Okay, we're going to discuss this for just a second. Are there any x values that don't work? Okay, I got a quick answer there. 0, okay? 0 might not work. Let's try it. F of 0 equals 1 over 0 minus 12, which is 1 over negative 12, which is the same thing as negative 1/12. That works. Negative 1/12 is a perfectly good number. So you're on the right track with 0, but 0 works in this function. Okay. Okay, question is, are there any other numbers that would work? And if you're watching this on video or listening or whatever, think about that before I tell you. Okay. Now we had suggestions. So how about a negative number? And then somebody said, well, no, negative number is going to be fine because if x is a negative number, a negative at minus 12 is going to just give you a more negative number. And that's going to work just as well as 0 did. You're going to have 1 over some negative number. Okay. But the one thing, okay, yeah, what 1 over 12 means is you're dividing 1 by 12, right? Is there any number you can't divide by? Don't say because I'm running, but if you can show me with your fingers, there a number you can't divide by. If you think you can't divide by 5, you hold up 5 fingers, okay? If you think you can divide by any number, you just say, okay, any number. Okay, well, the one number you can't divide by, I'm going to give it away as 0. Okay, let's demonstrate that. Let's take the number 10 divided by 2. Everybody knows 10 divided by 2 is 5. Why is it 5? Well, you can count to 10. 2, 4, 6, 8, 10 on your fingers, and you end up with 5 fingers, right? There, this equals 5. There are 5 2s and 10, right? what's 10 over 0.1? You don't have enough fingers to count that, but if you start counting by 0.1, you get 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9, 1. Okay, it took you 10 counts to get up to 1, didn't it? And you got to get to 10, so you're going to have to do that 10 more times, or a total of 10 times. There are 100 of these in 10. And if you try counting to 10 by 0.1, try writing them down. You can do it in a minute if you write fast, 2 minutes if you're not particularly fast. A little longer if you got to stop and think. Okay, and I'll even show you a little of that. Okay, you get 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9, 1.0, and you keep counting by 0.1s. Now you get 1.1, 1.2, 1.3, and I've written down 13 numbers already, and I'm not getting all that close to 10, right? Now you could write the whole thing down. It's not a bad exercise to do that, just to punish yourself a little bit. You can do it in a minute or two and see that there are 100 of these in 10. Now there's a rule for dividing by like a 0.1. You just move the decimal point over and stuff like that, but the rule doesn't tell you why it works. And one problem I have with math education, the way it's practiced, and the way the curriculum kind of dictates is people don't understand what division is. It's how many of these are in that. At least they don't understand it in this context. Anyhow, this equals 100. Now, what if you did 10 divided by 0? How many zeros does it take to make 10? You can't do it. The answer does not exist because you can't make 10 out of zeros. Okay. Is there a value of X that would make this thing 0? Okay, so our reasoning here. Okay, well, the problem with the domain is you can't divide by 0. So if you have 1 over X minus 12, X minus 12 can't be 0. Well, write X minus 12 equals 0. Add 12 to both sides by adding the equation 12 equals 12. Okay, if you add 12 on the left-hand side, well, negative 12 and 12 is 0. It's just going to leave you with X. And 0 and 12 is 12. So we've solved the equation X minus 12 equals 0. So now we have X equals 12. X minus 12 isn't in the domain. Okay, I'm gonna write the domain. Because once you see this restriction, it's pretty easy to apply it if you can solve the equation. So here is how I would write the domain. I write it as the interval from negative infinity to 12, but I'm using parentheses rather than square brackets. The parentheses tells you that negative infinity isn't included because negative infinity isn't a number. It's just something you can keep approaching. You never get there. So it's not a number, so you never have a negative infinity, no such number in the real number system. So it won't be included, but everything up to negative infinity will be included. And then 12, again, with a parenthesis after the 12, indicating the 12 is not included. And then 12, infinity, again with parentheses to indicate that neither 12 nor infinity is included. You draw a picture of that. Here's your number line. Here's where x equals 0. At x equals 0, if x equals 0 was included, we could put a point here. We can't put a point there if we're trying to represent the domain. So we do a little open circle to indicate that this is not included. And then we say, okay, everything from 0 off to the right is included in the domain, and everything from 0 to the left is included in the domain. But the one point where x equals 0 is not included. Make sense? So again, writing this out a little bigger because I had to kind of squeeze it in. Okay, now this U thing here means union. It means x can be in this part of the domain, or it can be in this part of the domain, and it's valid. And the only x that isn't in this part or this part is 12. And I said x equals 0. It should have been x equals 12. Okay. The denominator was 0, but it's x equals 12 that can't be included as we calculated here. Okay. There's another possible restriction on domain. Now, f of x is the square root of x plus 7. Are there any numbers you can't take a square root of? Okay, so we pretty quickly got a good answer here. You can't do the square root of a negative number. Okay, so restriction, square root of a negative. I'm going to write DNE, does not exist. And again, the reason is square root of a number is a number you multiply by itself. to get that number. If you multiply a negative by a negative, you get a positive. You never get a negative number, so there's no such thing as the square root of a negative number. I mean, there is if you extend to the complex plane, and we might talk about that to some extent, and you will talk about that in your pre-calculus, okay? Not particularly difficult, but that comes much later. Okay, so here, so x plus 7 has to be greater than or equal to 0. Well, we can add -7 equals -7 to both sides of this inequality, and we get x greater than or equal to -7. So what this equation says is we're okay as long as x plus 7 is greater than or equal to 0, because if it's greater than or equal to 0, it's not negative. Anything greater than or equal to 0 is not negative. So here is our conclusion. X has to be greater than or equal to -7. So we write the domain is the interval from -7 to infinity. Any number, including -7, because we're using a square bracket here on the -7, any number -7 or greater works just fine in this function. Okay. Now, again, I write the equation here. If you know how to look at it, you can see that x is going to have to be greater than or equal to -7. But if you have another function, g of x equals the square root of x cubed minus 5x squared plus 7, you wouldn't have a clue. And looking at that, I don't have a clue. Now I can do a little analysis on it, and you'll learn to do some of that later. Okay. And, okay, restriction. X cubed minus 5x squared plus 7 has to be greater or equal to 0. All you have to do is solve that inequality. And what I'll say about that is lots of luck. Okay. Now you get some idea of how you might manage that inequality along about halfway through the pre-calculus course. And I suspect, since I just wrote those numbers down randomly, that you're not going to be able to find an exact solution, but you get a pretty good idea of what the domain ought to be. Okay. So when I say write down the equation and solve it, you have to know to write down the equation and solve it. Because if you run into this, you are going to have to solve the equation. And I said write down the equation, write down the inequality in this point, in this case. Write down the inequality and solve that inequality. Write down this inequality and solve it. The way you might solve that is you figure out what the graph of this thing looks like, and it might be something like this. Okay. And then you say, well, if I can figure out what this point is and what this point is, right there is where everything's greater than or equal to 0. And I just figure out what x is here and what x is here. You don't have to remember that. Just telling you. Just keep you excited about what you're going to learn. Okay. I'm not sure how exciting that is to you, but okay. Well, there's one more idea, and it's one of the biggest ideas in mathematics. It's the idea behind calculus and much of what follows from calculus. So I'm going to at least give you the definition. Rate of change of y with respect to x. And we've only got 3 minutes, so it's going to be fairly abbreviated, but hopefully we can make a little bit of sense out of it. And I think OpenMath does a pretty good job of explaining the idea of a rate of change. And it's always valid. If you don't quite get the idea there, go to an AI. Say, hey, I'm struggling at the beginning of pre-calculus, this idea of rate of change. I know what the definition is. I know how to calculate, but I don't really understand it. Can you help me? You're probably going to get a pretty good answer. Probably. Okay. That's a good way to use AI. A bad way to use AI is, hey, here's a problem. I don't know how to solve it. Can you give me the solution so I can copy it down and get credit for it? Okay. That might work on your homework, but it ain't going to work on a test. So you don't want to do that. All right. Anyhow, rate of change of y with respect to x. Yeah, I've got to talk about average rate of change or instantaneous rate of change. We'll talk about later. It's a change in y divided by the change in x. And we can write that as delta y over delta x. And there are a number of other ways to write it. But these are the ways that I kind of prefer just conceptually so you don't get tied up in a formula that you don't completely understand. I can illustrate this with a graph. So I'm sketching a set of coordinate axes, don't really matter, but I'm sketching a curve. The curve starts kind of low toward the x-axis and kind of curves upward, and then it starts curving the opposite direction, but keeps rising. Okay. And I'm going to take the value of x here. I'm going to call x equals a, and the value here that I'm going to call x equals b. And I'm going to locate the points on the graph. Okay. I draw an arrow from where the x equals a point or line meets the graph, right? Directly over to the x equals b line, straight over horizontally. That's going to be how much x changes. X changes from here to here. Well, it changes that much. And the arrow moves from the first point toward the second. Okay. And the change in y then goes from the point where that arrow hits the x equals b line up to the point where the x equals b line hits the graph. And it shows you how much y changes between the 2 points. Okay. So the rate of change is just this divided by this. Now it has meaning, but we're already a minute over time and you probably have to get another class. So I'm going to let you do that. There are 3 assignments that are due over the weekend, okay? That might get you ahead of your pre-calculus class. We want to be a little bit ahead of the pre-calculus class because I want to do this course in such a way that you get the idea before you have to really do it completely, okay? Now, if I find that you just come in here confused over all the stuff you're doing, even though we're trying to stay ahead, I don't want you to be confused. Stop and talk about that. We can change the way the course is paced according to what you need. Okay?